So the goal and learning targets, it was just like mainly one thing. Um, Investigating variability, which tells you what about the data? How spread out it is. So center is like a typical value. Variability is the spread outness of the data set. So those values could be completely different, like you saw. I know toward the end, someone said, when I asked for the MAD, that it was 10. Like, no, that's the mean, but the MAD is 0. Like, so those numbers could be completely different. They talk about completely different things. So yeah, we did that with the data displays and the summary statistics like mean, median, IQR, all that stuff. And then we arrange data sets in order of variability given their graphs. So that's a great test question. You'll probably see something like that in the future. Yeah, so what we saw is what type of distributions tend to be least spread out. So usually, I mean, symmetric could apply to a lot of things. So not necessarily symmetric, but maybe like, because you could have symmetric and it be most spread too, which you're about to see. But like what else? Would you say bell shape is less spread out or more spread out? Usually less. What about bimodal? Would that be less spread out or more spread out? More, because we have the 2 peaks on, I don't know. We have the 2 peaks on each end, but the mean is still toward the middle because it's symmetric. So that's why like symmetric probably doesn't tell me much. And then what other distributions are there? Skewed. So would you say that that's more spread out or less spread out just in comparison to these? I would say it's in between. I don't know. It just depends on what it looks like. And then there's one more type of distribution. I don't remember what it's called. Uniform. Usually more towards the middle, but like definitely I would say bimodal tends to be more spread out compared to bell shape, at least usually. Of course, you gotta take every data set into consideration. So yeah, looking at that for the end is what we did. So now you have time to work on your lesson 11 puzzle piece. I believe there's 7 questions. Shooting for an 80% or higher. That should definitely not take you the entire hour. So we'll probably fill in the time with something else after that. Question?
Those ones in the middle, what do you do if I'm like while you're on a test? Does it really matter how the data is spread out?
What do you mean what I do with them on a test?
Like if you have to choose.
Oh, like when you were ranking them?
Yeah, like the less or more spread out, if you had to choose about the 2 during the test order out.
So, I think on a test, it'll be more straightforward. But if you can make an argument either way, like, you know, when it marks you wrong, like we can talk about it. But usually, like, when you're examining them, you have the ones that are obviously less spread out and the ones that are obviously most spread out, and then you just kind of fill in the middle. So in this one, there happen to be 2 possibilities because A and B are pretty similarly spread out. They both have a short whisker. Median is not in the center for this one. So it's like, you take those things into consideration, but you'll definitely have one that is definitely most, definitely. Any other questions on this? All right, so when is the mean better for talking about the data? When it's symmetric, so like, if we're using these dot plots, I would use the mean, and then what would I use for the spread, MAD or IQR? MAD, if we're talking about that the mean is better. And then stuff that is not symmetric, which we don't have that in this one. In this example, I'm using this one. Which one of these is not symmetric of the box plots? Which one looks definitely skewed? I would say B looks definitely a bit more right skewed compared to the other ones. So in that one, what would we use, mean or median? Median if it's not symmetric, and then IQR or MAD. IQR if it's the median, that's better. All right, so lots of good things covered in this lesson. So, yeah. Let me know as you have questions. We'll definitely go over the most missed ones if nobody asks any questions. That'll be some time for that. And yes, you can listen to me as well.
So if you look, and I know it's like teeny tiny, might be hard for wherever you're at, so I'll try to write it bigger. These are the actual values for the MAD. They're all symmetric, so the MAD would have been good for all of them. So this one had the MAD of 0. This one's 1.12. This one over here is 1.56 and 2.22 and 2.68. So now that you have actual values and you're not just using their distributions, you can now say for sure which one is the most spread out on this picture.
What MAD value is the most spread out? Right here, yeah, because this one has the highest MAD. So the higher the number, the more spread out. So which one is the least spread out? The MAD of 0, right? And then you can rank them from least to greatest from that. So this would be least, second least, third least, fourth least, and then most spread out. So now you actually have the value. So I guess on a test, if it was something you can calculate, like where they provide you the value, then you should for sure know the correct order. Because the higher the measure of variability, the more spread out it is. So that's it on that. Okay. So there's that.
Usually I look at the statistics and this one had 0% of people got it correct. So then I went back and checked to make sure it allowed partial credit. So it'll rescore. So you could see at least which of your guesses were right. And then you can kind of narrow it down from there.
But we're selecting all the distribution shapes for which the median could be much less than the mean. So before I put that, it would allow partial credit. If you didn't get it exactly right, you just mark it completely wrong. No, I always do partial credit. However, like if you pick a wrong answer, it usually deducts from your right answers, if that makes sense. So when the data is what, you would expect the mean and median to be the same. So what shape would we expect the mean and median to be the exact same? When it's symmetric, so mean / median are the same. In that case, any others that are symmetric, we're also not going to pick because the question's asking for which the median could be much less than the mean. So which else is symmetric that we're going to exclude from our answers? Bell shape, and I should actually probably. So then what the answer is. So yeah, we're gonna exclude bell shapes because the mean and median should match. What other ones should we exclude? So bimodal is symmetric, however, that is one of the correct answers. Why, I don't really know, but it is like I checked the answer in the book. It did say that for bimodal, you could expect the median to be much less than the mean. Emphasis on could. So I guess not like a perfectly symmetric bimodal, I'm assuming like a roughly symmetric bimodal, maybe to where it's like this. You know, low in the middle, and maybe like kind of high, but not as high. So, or maybe let me have that wheel. So this is still a bimodal shape. But we would expect the median to be a little bit more this way, since more of our data is this way. Whereas the mean is like, could be a different number. Does that make sense? So not like 100% perfectly symmetrical bimodal, but maybe one that is a bit more heavy on the left side. So bimodal should be one that you pick for this practice question. On the test, it should be more straightforward. And then what other one would you expect the median could be much less than the mean? You left, you right, or both? Okay. So maybe let's draw it out. If it's skewed left, that means the void would be on what side? On the left side. So if I'm drawing like a skewed left histogram, it could look something like this. And you could even maybe have like an outlier, who knows? But like the void is on the left side. So in that case, the median will, what do outliers do to the mean? Hold it in what direction? So if this is my graph and this is my outlier, my mean is being pulled left or right. That should be pulled left. So my mean is being decreased because of that outlier. However, my median is still probably more over here where the bulk of my data is. So in that case, the mean is lower, the median we expect to be higher. So we wouldn't pick the skewed left option because of that. Does that make sense? Okay. And then in that case, could we pick skewed right? Yes. And then it would be flipped. It would be more of the data is on the left side. Something like this. All right, if I have an outlier, that would probably make it skewed right then, because there's probably an outlier. That pulls the mean higher, even though my data is mostly on the lower end of the spectrum. So that means my median is expected to be where the bulk of my data is. So it would be expected to be lower than my mean. So these two would be the answers for that. Skewed right and bimodal. So questions on that one? Questions on other? Okay, I think they're not randomized anymore. You might give me some of the numbers. Is it this one? Okay. This one, yeah, okay. So we're arranging in order from least variability to greatest, and so they want the least toward the top and the greatest toward the bottom. Didn't mean to do that. I'm just trying to zoom out. Okay, so we have miniature golfers attempting to finish 100 holes under par several times.
what it's about really doesn't matter if we're talking about variability. We're looking at how spread out it is. So in that case, and yours might be in a different order. If these are my 4 box plots, which one is clearly the most spread out? Like we can start there.
This one, this top one? Or are you going? No. This one is a little off, okay. So these two, when you're considering them, you're gonna wanna look at like the range and the IQR. Cause obviously, like, we normally don't use range a lot, but if we're talking about how spread out a box plot is, that could help. These are roughly the same amount of spread as far as the range goes, so that doesn't help me as much. When we're narrowing it down, look at how spread out the middle 50% is. The smaller the box, the less spread out it is, right? Because that's 50% of the data. If it's mushed together, that means that 50% of the data is closer together. So between the two that I colored, which one is more spread out, the top or the bottom? So I should drag that one all the way down, because it wants the most variability at the bottom. So I'm going to drag it all the way down. Second most variability would probably be what then? This one? Or no? So that should be second to bottom, because we said this one's, wait, did I mess it up? Oh, wait, no, this one. Yeah, that's the one we said. So this one's a little less spread out because it has the box closer together. They have about the same ranges. This one, since its box is smaller, less spread out than that one. Now we have the first two on the top. Do you think that this one is less spread out compared to that one, or do you think the order is, what do we think about the order? We want the least spread out on top. So the order it is right now, we're seeing is good, and I think so too. If I look at my range, it's going from about 41-ish to like 58. So that's like a range of, what is that, 17? About, I don't know, think about 17. And then over here, this range goes from about 48 to 66. What is 66 minus 38? Yes. 18, so similar ranges. I'm kind of doing mental math, so I might be off by one, so. And then when we look at like the IQR or the box, the one that is less spread out, like if I did the IQR for this one, what, 64 minus 55? Nine. And then when I do the top one, I have like, what is that, 54, 55 minus like 44. I think that's also 90. Or no, that if I'm doing 55 minus 44, that's like 11. So technically, I think they're gonna say that this one's less spread out. So I think we're gonna have to drag it, and we'll see. I'll check the MCQ right now. But I think based on the statistics, since this one has a less IQR, I think they're gonna say that this one is less spread out. So let me kind of take a picture and see. Okay, so correct answer setup.
let's compare. Sometimes it is wrong, so we'll just have to, I'll have to check the book probably. But if we're going from least variability to most, then we are completely off. So I'm guessing what they want is for you to look more at the IQR versus the range. All right, so sorry. Here's what it wants it to be, so you could change it to that. So we're going based off of the IQR. So the smaller the box, the less spread out it is. I'll kind of add that to here. I'll put hints, use IQR. All right, sorry about that one. It just depends on if you're looking at it as a whole or if you're using IQR. That would change it. So questions on this one? Okay, I'm gonna put partial match allowed. All right, any other questions or requests on this one? Okay, we were gonna play a game of bingo, but I think this one just took a little longer than normal. So we'll save the bingo for tomorrow. Anything we do that is like more project-based or things like that goes in the either project category or assessment category. I'll always let you know. We don't have an assessment in for Math Lab yet, so I'm thinking that bingo game that we play tomorrow will be an assessment grade. So just make sure like we really participate on that one, that we turn in our work at the end. That'll be tomorrow. Any questions?